And welcome to the Evidence Reasons Wild Frontier. This is a recording. I'm testing out a new system. I hope you all are enjoying the video that you're seeing here. I'm set up in a new computer called M2, and with a lot of difficulty I set up the green screen behind me. The picture you see is of my home. I believe sometime around 2017. It's a photograph of my beloved mother. That's her portrait. What you are seeing though behind me is a picture of my home. It's not actually, I'm not recording actually in this spot in my house, but I thought this is such a pretty picture of my home that I wanted to use that instead of trying to do this live. Plus I don't have to clean up my room. I don't have to clean up the room. And this studio is kind of very comfortable. I can get a lot of heavy equipment here. It wouldn't be appropriate to have all this equipment right in this particular room of the house. Sadly, some of the furniture that you see behind me is now moved out, and it's kind of sad. Tonight, I'm going to be relating mathematics, physics, and Christianity. And this is something dear to my heart, as these topics have brought me closer to God. Ironically, that we could find it. It's actually in the field of physics that I found evidences of God, such as even the claim that quantum mechanics does point to an ultimate observer, which is an almighty, all-knowing God. And there's some other things that we'll cover here. This topic came about because Mr. Jetty89 had commented, emailed me about a video I had on Clifford algebra, Hamiltonians, tensors, and differential vector calculus. Now, I know a little bit about differential vector calculus, but it gets a little funny. I didn't, tensors were really a hard topic. A step above that would probably be the Hamiltonian, the Hamiltonian quaternions, and I don't know of anyone that really uses those extensively in physics. I've certainly not seen it in my classes. But Clifford algebra has been, and Clifford algebra was important in the discovery of antimatter. William Dembski had this tremendous essay that tried to say, hey guys, think about it a little more deeply. It looks like the universe was designed for us to understand something. We could have lived in a universe that was incomprehensible, one that wouldn't at all point us to God. It says in Romans 1:18 through 20, paraphrasing here, for his, that is God's, invisible attributes are revealed, his divine nature and his eternal power are clearly seen in the things that are made. And it also says in Proverbs 25:2, it's the glory of God to conceal a matter, it's the glory of kings to search it out. So paradoxically, while God reveals himself in nature, it is also in a way that is hidden enough that if people want to blind themselves to it, it'll be very, very easy for them to do it. But still, in a sense, they have no excuse because they have to go through a lot of mental gyrations to suppress it. I'm seeing this with multi-universe theories, etc., etc. So it's not just the fine-tuning for life, it's also the fine-tuning for discoverability. So independent of one's cosmology, this character of the universe that enables science to move forward seems divinely ordained. So let me cover this essay. And I'm supposed to be able to see it by now. Let's see if I could bring it up. There it is. So let me just scroll it to the right position. And the title of the essay is The Last Magic. It was actually a book review that was published in Christianity Today, Books and Culture, August 1999. It's still a fabulous essay. by mathematician and theologian William Dembski. Dembski was also well known for his work in the intelligent design movement. Let me just adjust this a little bit here. If mathematics is about finding solutions to well-defined problems, then philosophy is about finding problems in what previously we thought were well-settled solutions. Mark Steiner's The Applicability of Mathematics as a Philosophical Problem mirrors both sides of this statement, admitting that mathematics is the key to solving problems in the physical sciences, but also asserting that this very applicability of mathematics to physics constitutes a problem. What sort of problem? According to Steiner, the reigning ideology or background belief for the natural science is naturalism. Typically, naturalism is identified with the view that nature constitutes a closed system of causes that is devoid of miracle, teleology, or any mind-like superintendence. An immediate consequence of naturalism is that it leaves humanity with no privileged place in the scheme of things. It's this aspect of naturalism that Steiner stresses. Naturalism gives us no reason to think that investigations into nature should be, as Steiner puts it, user-friendly to human idiosyncrasies, and yet they are. Steiner's point of departure is Eugene Wigner's often reprinted article, The Unreasonable Effectiveness of Mathematics in the Natural Sciences. Wigner concludes that article with a striking aphorism: the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. Throughout the article, Wigner refers to the miracle and mystery of mathematics in solving the problems of physics. Yet although Wigner leaves the reader with a sense of wonder, he does not indicate how this sense of wonder translates into a problem that demands resolution. Enter philosopher Mark Steiner. By the way, as a side note, that Wigner, I believe, published that essay before or around the time that he was awarded the Nobel Prize in Physics. Steiner's project is to take Wigner's pre-theoretic wonder at the applicability of mathematics to physics and translate it into a philosophical problem for naturalism. The applicability of mathematics to physics is not a problem for a mind-first Platonic worldview or a mind-first Pythagorean worldview or a logos-first theistic worldview. It is, however, a problem for a nature-first impersonal worldview. According to Steiner, naturalists are in no position to expect that, much less act as though mathematics should assist in the discovery of physical insights. That naturalists do count counts against their naturalism. It is important to understand that Steiner is not simply appealing to the success of mathematics in resolving the problems of physics. It is not the isolated successes of mathematics as applied to problems in the physical sciences that for Steiner constitutes a philosophical problem. After all, there are many instances where mathematics has failed to be successfully applied to problems in physics. The problem, rather, is the global success of mathematics as a research strategy for facilitating discovery in the physical sciences. This is a subtle point, and one impossible to convey without actual case studies from mathematics and physics. Indeed, much of Steiner's book consists of such case studies. Consider, for instance, the physicist Paul Dirac's discovery of the positron and antiparticles more generally. The positron is a particle just like an electron, only with a positive charge. Yet when Dirac proposed the positron, there was no experimental evidence for it. Indeed, there was no reason to even expect its existence. Why then did Dirac propose such a particle? Dirac was at the time trying to understand the Klein-Gordon field equation and the energy levels it assigned to certain quantum systems. He wanted to extend this equation relativistically to the electron, but he found that the only way to do so was by factoring it. Unfortunately, the equation resisted factoring over the real and complex numbers. Dirac therefore brute forced the factorization by introducing higher dimensional number-like objects. The property where these objects differed from ordinary numbers was commutativity and multiplication. The factoring work gave Dirac the relativistic solution he wanted for the electron. But because the number-like objects he introduced had a higher dimension than the ordinary numbers, Dirac's solution to the Klein-Gordon equation also yielded extra solutions corresponding to the extra dimensions of his number-like objects. One of the solutions suggested a positively charged particle that in every other way was identical to the electron. What started out as a mathematical trick designed to factor an equation and yield insight into the electron therefore yielded an entirely new particle, and indeed an entirely new type of matter, antimatter, the discovery of which fundamentally altered our understanding of the physical universe. Dirac's mathematical manipulations and physical speculations would have remained just that, except for two facts. In 1932, Carl Anderson experimentally confirmed the existence of the positron. In the 19th century, mathematicians had already constructed the number-like objects that Dirac needed to factor the Klein-Gordon equation. They are known today collectively as the Clifford algebra, and Dirac had to reinvent it to get a relativistic equation for the electron. Where the philosophical problem for naturalism in examples like this, and Steiner makes clear that such examples are widespread throughout mathematics in its application to physics. The problem is that mathematics is a thoroughly human enterprise. Nature may condition us to see patterns that are readily perceived, that, as it were, ride on the surface structure of nature. At the same time, nature should be indifferent to human idiosyncrasies. Thus, the problem for naturalism posed by Dirac's reinvention of the Clifford algebra and subsequent discovery of antimatter is that it occurred entirely through the manipulation of humanly constructed notations, and with attention not to physical reality, but to human convenience. Equations that are factorable are much easier for us to deal with than those that are not. Factorability, however, has no physical significance. A world indifferent to us has no stake in rendering itself intelligible to us by making the equations that describe it factorable through some mathematical device, like the Clifford algebra. And yet, precisely such idiosyncratic manipulations of humanly constructed notations result in genuine and previously unsuspected physical insights. There really is a problem here for naturalism. As Steiner notes, in every other area where human constructions are manipulated according to human convenience, naturalism expects and indeed confirms no profound insight into the structure of the world. The rules of chess, for instance, do not yield insight into the structure of the atom. The study of palindromes, sentences that read the same backward as forward, e.g., Madam, I'm Adam, tells us nothing about the first 3 minutes after the Big Bang. Indeed, the claim that human constructions manipulated according to human convenience supplies insights into reality the claim that human constructions manipulated according to human convenience supplies insights into reality belongs to what traditionally has been called magic. The view that what humans do in the purely human world, the microcosm, mirrors the deep structure of the world at large, the macrocosm. Naturalism has no place for magic, and yet the applicability of mathematics to physics is magic. According to Steiner, mathematics is the last redoubt of magic, but one that stands secure and is in no danger of naturalistic debunking. This is a user-friendly world where we humans are users and where the tools of discovery that renders the natural world friendly is mathematics. In place of naturalism, Steiner opts for an anthropocentrism which affirms that humans do have a privileged place in the scheme of things. Steiner's anthropocentrism falls short of the full-blown metaphysical position like Judeo-Christian theism, Platonism, or Pythagoreanism, but it stands sharply against the widely held evolutionary view that humans are mere accidents of natural history. The applicability of mathematics as a philosophical problem is a technical contribution to analytic philosophy that presupposes not just a background in philosophy, but also extensive exposure to mathematics and physics. Readers without the relevant technical background should be prepared to find no more than 20% of the book intelligible. Even so, Steiner's challenge to naturalism is accessible, powerful, and well worth pondering. William Dembski is a fellow of the Discovery Institute. He is author of The Design Inference, Cambridge University Press, and editor of Mere Creation InterVarsity. His book, Intelligent Design, The Bridge Between Science and Theology, is forthcoming from InterVarsity. It's actually already been published. Great book. And thank you all very much. Isn't that a beautiful essay? Evolutionary biology just seems like a farce by comparison to physics. And Jerry Coyne said so. In science's pecking order, evolutionary biology lurks somewhere near the bottom, far closer to the pseudoscience of phrenology than to physics. And when you read essays like this and you actually study it, you see that. So with that, let me close out with some beautiful music. Thank you everyone for joining today, and have a wonderful and blessed evening. Glory and honor to our Lord and Savior Jesus Christ.